Hello friends, welcome back to my video, and in today's video we are going to cover a topic of entropy. This part will be covered in three parts, which will be around 5 to 6 minutes. And yeah, I promise this time there will be all three parts, not like another video. And this part or this video is in this video I'm going to tell you about the entropy. What is entropy? The next video that will come will be telling about the topic, the heading that I will give it. I choose it to give will be that what if we keep a hot bar and a cold bar together. And the third video that I will upload is that if you shine a bright light on a particle of soil, it is not surprising that a new plant grows from it. So first of all, in this video it is an introductory video of entropy. What is entropy after all? So first of all, my name is Aditya Singh Rana and you are watching ASR Aditya Singh Rana YouTube channel. Let's start today's video without any wasting of time. What is entropy? In very simple words, we can say it is disorder of something. Like more than a scientific term, I would rather say it as English term, because we can relate it anywhere. Like if students are studying in a class and teacher is present in that class, then the entropy means disorder of those students will be much lesser than when the class would be over and teacher would have stepped out from the classroom. The student will be rushing here and there will be a lot of chaotic motions over there, so that will be much higher entropy. So rather than a scientific term, we should think it as a English term. But here, as you know, I make videos on science only, so we are going to cover the scientific part of it. Now first of all, what is entropy? Entropy is disorder of anything, or we can say in how many possible ways some given things are present in some given area. So think of ocean is a lot of vast, and from that ocean just pick up a molecule or just pick up an atom of water, H2O. Now after you point out that atom, can you tell me after 1 year or 2 years where that atom will you find? Maybe it will be, if you take a atom near Indian Ocean, maybe you find it near Atlantic Ocean, maybe you find it near Antarctica, maybe you find it near Pacific Ocean, or maybe you find it in your glass. Yes, after all, we all are connected together. So now this is what entropy is, that specific atom that we have pointed out from that whole sea, from that vast ocean, can be in your cup of tea. So that what entropy is, disorderness. The world is vast, the number of amount of possibility of that particular atom is a lot. I mean a lot. So this is what entropy is. Now why we have to study entropy, or why we discovered entropy? So first of all, entropy, you can say that everything, first law of thermodynamics say that overall entropy of universe always, remember it, always increases. Okay, let's take an example of it. Like we are running an AC, so it cools. Okay, it cools. If anything cools, it vibrates less. It means it have less possibility of randomness, means it have less entropy over there. Means we have a room which is colder, let's suppose 10 degrees Celsius, and then we have another room which is hotter, let's suppose 50 degrees Celsius. We know, we have studied in 9th and 10th grade, that if something is hot, then its particle, its atom will be vibrating much more faster, and they will be the hotter the particle are, the more the motion show to us. Now what I'm trying to convey here, the cold room which is having 10 degrees Celsius, and the hot room which is having 50 degrees Celsius. So in the cold room, the particle will be moving slower. Let's suppose, okay, only suppose, I say suppose. So let's suppose the particle in the cold room are vibrating, oscillating or moving with the velocity of 10 meter per second, whereas in the hot room the particle are vibrating, oscillating or moving with 25 meter per second. So now in the hot room we know that the particle are moving much faster. So in a given particular interval of time, okay, let's suppose in 2 seconds I point out a particle from the cold room, and I point out a particle from the hotter room. So what is the randomness between those two rooms? Like if I take cold room, after 2 seconds there is much more less chance, much more high chances to find that particular particle at the near that point. Whereas if we talk about the hot room, there will be much lesser chance to find that particle nearer to that point from where we extracted that particle. So this is what how entropy works. The temperature increase, entropy increase. The temperature decrease, entropy decreases. But here I was saying the first law of thermodynamics, it states that entropy never decreases. So how is this? Actually, the first law that I stated was incomplete. The entropy, the total entropy is never less in the whole universe. We have systems. In grade 11th, you will come to know about the systems. There are three types of system. First is open system, second is closed system, and third is isolated system. Open system are the system which first of all, what are surrounding also, yeah. So system is a place in which you do your observation, whereas surrounding is the rest of the thing. You can say if we minus system from universe, the rest is our surrounding. So system, what are system? Yeah, our own, what are system? System are of three types. One is open, closed, and isolated. Open system are a system those can exchange matter and at the same time exchange energy. Whereas if I talk about closed system are those systems which do not exchange matter at all, but still they exchange energy. And then we come to know about isolated system. And remember, there is no physically known isolated system, perfectly isolated system till this date, which is 31st October 2025. So yeah, isolated system. Those system are the system which those system are the system leave it. Those system are the system which neither exchange matter nor they exchange energy. Means the energy in that system and the matter in that system will remain constant. Okay, so one example for each, or maybe two example for each. First, take of open system. Think we have a pan, not a pan, but a any utensil in which you are boiling a water, and you haven't covered that utensil, and the water started to boil. What will happen? Everyone know evaporation. The water will convert to the steam, and then steam will escape from that utensil. So here what is happening, that actual mass of that water is decreasing at constant pace, because the water that was in the form of liquid is now converting to the vapors and escaping from that utensil. So therefore we can say it is an open system. And even, yeah, obviously if anything is if the matter is escaping, then it's nothing for energy to do. It can easily escape that thing. Now let's come to the another system, which is closed system. Closed system, as I told, matter does not exchange. So the example of is the same, but just you cover that utensil with something like a plate on that. If you put a plate on that utensil, what will happen? The water that is getting converted into vapor will condense after contacting with the plate because the plate is much colder than compared to the heat of the vapors. So it condenses, and those becomes the water that when if you have ever noticed, you boil boiled water and you have covered it with a plate, and when as soon as you remove the plate, you will see the liquid, the water sticked on its surface. It is none other than condensation process. So condensation take place, therefore no matter escapes from that utensil. Yeah, little leak is a different part, but here we are talking generally. So no matter escapes from that particular utensil, but again energy do. If you switch off the gas, the water may remain hot for next 5 to 10 minutes, but eventually it will lose its energy, and after all it will become cool. The water will become cool because it is losing its energy. This is closed system. And third is isolated system. As I earlier told, there is no perfectly isolated system in this universe except universe itself. Till that what we know. So except universe, there is nothing another perfect isolated system. But still, taking as general, we can say that thermos, like of different companies, Pexpo, Milton, many companies create thermal thermos. Now we can consider them as isolated system because they conserve the energy, they conserve the heat energy inside them for next to 5 to 6 days. So this is what were system. So here we were talking about first law of thermodynamics. So how does it relate? So why I told you the system, because it was necessary to understand it. Now think, we have working AC. The AC is working at constant speed, constant volume, and constant pressure. Now the AC is cooling, the room is totally closed, totally sealed. Now the AC is cooling the temperature of the room. So if the temperature of the room is cooling, that means the entropy should decrease, right? Then how come the entropy is increasing overall? Now let's focus on the other part of the AC, condenser. The condenser is regularly producing heat. The heat produced by the condenser of the AC is much more. It is releasing much more energy than the AC is cooling inside the room. That's why if we take out we subtract, okay, we subtract the entropy that is being increased by the condenser from the entropy that is decreased by the main AC, that will be greater, that will be positive. This means that entropy is again increasing. Here, remember, we are talking about universal entropy, not a specific area, a specific place. We are talking about universal entropy. So that was all I want to tell in this video. And in next video, remember the heading. Think about it. Think about what you think, that what I mean to convey a message to you from the heading. What will happen if we keep a hot bar with a cold bar? It has obvious answer, but actually is it? We will meet you in next video. Till then, take care. Jai Hind. Bye bye. Bharat Mata ki Jai.